Partial automation is an emerging accessibility technique that controls parts of games for players. This makes games more accessible, but controlling parts of games for players can also make them confused about what they're doing and what the automation is doing. In this paper, we address this through a new grounded theory of automation confusion in games, which helps explain why players get confused and what designers can do about it. So, what is partial automation? Games can be challenging and assume that players have high levels of manual dexterity, which can exclude players with disabilities. Games can also be complicated and assume that players have deep game knowledge, which can exclude novices. To help with this, some games provide assistive features designed to make them easier to control. In Bayonetta, for example, players using the automatic mode can play using only one button. Specifically, the game's AI takes over the tasks of moving the avatar, aiming, and selecting the best attack to do in a given situation, and the player presses the Y button when they want to do an attack. This greatly simplifies play, making the game accessible to anyone who can press a button, at the cost of removing some agency from the player. We call these sorts of features partial automation because they automate part of how the game is controlled. Partial automation has previously been shown to make games more accessible to players with disabilities by controlling the inaccessible parts of games. This personalizes games to each player's abilities, enabling players with radically different abilities to play the same games. Partial automation may also make games more accessible to non-gamers, who are unfamiliar with games and have difficulty controlling them. Non-gamers may not want to play games for their own enjoyment, but they may want to play with their friends or family without feeling unskilled or deficient. As a concrete example, the man shown here is playing a game called Dino Dash with partial automation. An AI agent makes the red dino avatar move around, and the player makes it do a shout attack by pressing the button held in his mouth. This makes the game accessible to this player, by controlling the parts that he cannot. But we have found that this can also make players confused about how games are controlled. See how he's tilting his head in different directions? This player believed that he could control the dino's movement by tilting the button in his mouth, although he actually could not. When the player and the automation share control at the same time, players may have difficulty understanding what the automation's doing, and correctly attributing automated actions to the automation, and their own actions to themselves. Automation confusion occurs when players develop incorrect mental models that make feedback from the game difficult to interpret, and often lead them to become even more confused. In fact, numerous automation accidents in the wild indicate that automation can have devastating consequences for users' understanding of interactive systems in general, causing them to hurt themselves and others in their confusion. This problem is not yet well understood, and designers unaware of automation confusion may find that automation designed to help users ultimately hurts them instead. So we performed a low-risk study to elucidate how and why automation confusion occurs in partially automated action games. This presentation has 3 sections. First, we will describe our study's methods and explain how the games were designed. Next, we will present our grounded theory of automation confusion, and finally, we will discuss automation confusion's implications for game design. To investigate automation confusion, we created 2 action games controlled using one button with different forms of partial automation. Ninja Showdown is a simplified fighting game, like rock, paper, scissors, in which the player controls one type of attack while the automation controls the other 2. Spelunky is an open-source re-implementation of the popular action platformer of the same name. The automation makes the avatar move and jump around, while the player can tell the automation to select and perform actions using a single button. In total, 10 non-gamer participants were recruited to play these 2 games. We chose to study non-gamers, people who do not play games for their own enjoyment, because partial automation may help them to play with their gamer friends and family. We also expected them to be especially susceptible to automation confusion due to their lack of familiarity with games. Participants played each game for approximately 15 minutes while a researcher observed, asked questions, and periodically prompted them to think aloud. After playing both games, participants were interviewed about their experiences, their understanding of the games, and their beliefs about how they controlled their avatar's actions. These data were analyzed using classical grounded theory methodology from a constructivist perspective. We recruited more participants until we stopped generating new ideas. And we collected more data until participants confirmed that the ideas we generated already captured their experiences. We categorized these ideas into different types of mental model errors, attitudes towards the games, behaviors resulting from confusion, and sources of confusion. Periodically, we organized observations of automation confusion into what we call confusion episodes, storyboards intended to help us make sense of interactions between these categories. Let's take a look at one of these confusion episodes to illustrate how the automation in Ninja Showdown confused P2. In Ninja Showdown, players can make their avatar on the left use the sword attack by pressing the space bar, but P2 believed that she could make her avatar use the bomb by pressing the B key. In an earlier round, she guessed that the B key controlled the bomb, and the automation coincidentally selected the bomb after she pressed it. In this round, P2 decided to once again press the B key to make sure it did what she expected. Coincidentally, her avatar used the bomb, and P2 misinterpreted this as feedback reinforcing her belief that she controlled the bomb. After this episode, we asked if her avatar did what she expected, and P2 said,
"Yeah, I pressed the B and you got the bomb."
Now let's dissect what happened by decomposing this confusion episode according to the categories of our grounded theory. P2 over-attributed her avatar's actions to herself, believing that she could control automated actions, which is one of the types of mental model errors. Consequently, P2 misinterpreted feedback from the game in a way that seemed to confirm her erroneous belief that the B key made her avatar use the bomb, which is one of the sources of confusion. Interactions between players' mental model errors and the sources of confusion they encountered in the games often produced and reinforced players' superstitions. Players who went looking for ways to control actions they could not often discovered methods they believed controlled these actions. Players who tested these methods often misinterpreted feedback from the games in ways that confirmed their superstitions. Definitions for all of automation confusion's concepts are articulated more precisely in the paper. 9 of our 10 participants experienced severe automation confusion, indicating that partial automation can confuse non-gamers. Although the games were designed with guidance from prior work in HCI, the prevalence of automation confusion in our participants indicates that more guidance is needed, so we provide the following design guidelines. Partial automation should provide ways for players to control the specific actions they want to control. Although partial automation is intended to simplify games, some complexity may be desirable if it helps players avoid superstition. Designers of partially automated games should rigorously test the comprehensibility of their game's feedback with target players. Players approach games with their own set of expectations for how they will work, so feedback that can be faithfully interpreted by some players may be misinterpreted by others. Partially automated games should provide training for non-gamers to front-load their learning and thereby minimize the learning they do during play. Confused participants played a frustrating metagame of trying to figure out how the game was controlled, which might have been avoided with more practice and instruction. Partially automated games should teach players how to cooperate with their avatars by telling them what to do when they dislike their avatar's behavior. Participants had difficulty developing gameplay strategies around the automation, and were unsure of what to do when they needed the automation to act. In summary, partial automation can make games more accessible, but it can also make players confused about how the game works. The automation can lead players to develop erroneous mental models if designers are unaware of automation confusion. So, we constructed a grounded theory of automation confusion to help designers and researchers who read the paper to identify and address automation confusion in partially automated games.